Do you have all your ducks in a row? This is actually a figure of speech that is said in English. Having your ducks in a row means that you have everything ready to do something complicated. That's also because ducks often walk in a row. Suppose that two lines of ducks are walking along the parallel tracks of parallel rails of a railroad track. One line of ducks has 4 ducks, which are spaced 1 meter apart. The other line of ducks has 3 ducks, which are spaced 2 meters apart. How many different positive areas can arise from drawing triangles whose vertices are at the ducks' locations? With a question like this, it's a geometry problem, but there's no diagram. So we have to convert this into a picture. Let's draw the railroad track. Railroad tracks have 2 parallel rails. That's very important. Now, there are 2 lines of ducks. Ducks are green, so I guess I'll use green here to draw them. 1, 2, 3, 4. And here is one line of ducks, which has 1 meter between ducks. Here's another line of ducks, which has 2 meters between ducks. Notice that the question doesn't say whether these are lined up perfectly with those. So that means the answer probably doesn't matter either. It doesn't depend either. And now I'm looking at triangles where the vertices of the triangle are at the ducks' locations. For a question like this, since it's asking for the number of different areas, we have to think about what formula we want to use for the area of a triangle. And here, it seems like half base times height might be the best way to do this. For example, in this triangle right here, we have this base, and we have this height. Aha! But once you look at this, you see that all of the triangles that I could draw all have the same height. So actually the whole problem becomes, how many different bases can you have? And that's the main insight in this kind of a question. So the question has been converted into how many different base lengths. You see, once I wrote it this way, it also helps you to not make a mistake of saying that this triangle here is different from this triangle here. See, these 2 triangles actually have the same area because they have the same base length and the same height. That's an important piece here because otherwise it's possible to get confused and to count the same area twice. But now, how many different base lengths can I have? If I try to write them down, that's probably the easiest way to see a pattern. On the top, I can have base lengths of 1, 2, or 3. From the bottom, I can have base lengths of 2 or 4. You see that 2 appears twice. And so what that means is that the number of different base lengths is just 4. And so actually, the answer to the entire question here is 4. And the secret to getting your ducks in a row is to interpret the English into a diagram, and then to understand what about that diagram is the most important. In this case, the most important is just the distance along the rail.